Yeah, Brad here with another quick video for you. I've got a Joust complete board set on the bench with original linear DC power supply, completely rebuilt, restored, and I'll go over everything with you. This is for a customer of mine, Chris. He's sent in a lot of boards over the years. He's usually pretty patient. If I've got somebody that's in a bigger rush, I can bump him back a little bit, and he's usually got a bunch of projects going, so he can kind of shift gears and work whatever he's got parts for. So this one worked out because I've been sitting on it for probably about a month, which for me is a long time. So let me switch over to the bench cam, and I'll kind of go over what I did on the boards, and then we'll do a little gameplay, and I'll talk through, a few things with that. So let me switch over. There you should see the bench now. So again, Joust board set. Interesting, we've got a Rev D MPU here. And it is the original one. The serial number here matches 946 with the ROM board. Usually most of the Joust you see Rev B or C, so this is a D. And on the Rev D too, back here, these four inductors, they added these for, FCC was kind of requiring them. These things had some emissions, some RF emissions, where they were afraid, pacemakers and things like that would be affected. So they kind of upped the regulations back in this period. So Williams responded by adding these inductors here, and they did a few other little mods, but that was the primary ones. And originally, the inductors in these three locations here, they stood vertically. They're just little copper inductors here, coreless, air core they call them. Like this one here has a ferrite core coming in on it. But in any case, these ones sat vertically and they tend to bend and break and cause a lot of problems. They're just not very robust design. So I've sourced these ones for the same value. They're 2 microhenries, air core as well. I have to do a little bending to get them fit, but they look really nice and they kind of match the original one here. So we've also got 3 new Nichicon electrolytic filter caps. I've got a tantalum here that's used for the soft start. Again, this kind of this capacitor along with the resistor it's paired with create what's known as an RC time constant, and it allows the 5 volts to come up on the board and get stable before it releases the reset on the 6809E CPU. So originally that was an aluminum electrolytic, and I put a 22 microfarad tantalum, which is the same value. Um, Back here, also took the AA battery holder off and replaced it with the CR2450 holder. I fill in all the holes real nice with solder, and I do the ground connection here. You can see kind of through the shadow of the board that ground side of the battery ends up here, and I just create a little jumper on the back side that jumps from this pin to this ground plane here. And then what else did we do on the board here? We've got all new Molex headers. This is a video out. This one here is for the memory protect switch, and then we've got power here. And again, these are all the square pin Molex. We did clean the whole board, wipe it down. Didn't find any major smoking guns here with any problems. I did pull both the decoders and the CPU, straighten and clean the legs on it. Turned out real nice there. And then back here on the ROM board, these little connections are for just me to pick up 5 volts for my video converter board for the test bench. New Molex headers all the way around, three positions there. We've got 2 new Nichicon filter caps. We've got a new 3M ribbon cable. I make these up. And again, generally just went through and wiped everything down, cleaned everything up, and it's working real good. IO widget board, same thing here. New ribbon, new cap, 2 new 10-pin Molex headers. One of the original Molex headers looks like from the harness, some of the vinyl on these wires, certain ones, they kind of liquefy over years, the polymers that hold it together, and it was in the connector. I don't know if I can see it here. Here's the bag. I do return all the customer's parts, and this is a big bag of parts. There's the old battery holder and some of the big caps from the linear supply, but there's that one with the green in it, a 10-pin. Pretty bad. So I would recommend the customer take a look at the harness as well, Chris. And then back here on the soundboard, again, this got the full treatment as well. All new electrolytics. There's 8 of them, I think. We've got 3 here, 2 here, and then actually this one had 9 because of 10 microfarad here. I put a tantalum, and we've got some of these decouplers here, the yellow ones are tantalum as well. We've got a new bridge rectifier over here. Pulled the CPU, pulled the EEPROM, cleaned the legs, straightened them, and just went through and tested the whole thing. Crystal back here sits a little high, got him lowered down, fitting flush with the board now. And then the DC power supply. So these turn out real nice when I do them. The heatsink, pull the both power transistors, clean them, put new sill pads underneath them in lieu of the original um, mica with heat-seeking compound. They're kind of messy. They don't transfer heat as well as these sill pads do, and these are electrically non-conductive, so they do electrically isolate the transistor from the metal heatsink as well. They work great. And then I do put a new 7-pin Molex header here, connector on the harness side with the trifurcon pins, and then I also, you can see here the little polarizing key, they call it, that plugs it, because you cut the key on the mating board PCB header, so it can only be plugged in one way. I do replace those, and then all the headers on the board are new Molex, two 15 pins, a 6 pin, and a 7. We've got a new, all bridge rectifiers are new, including this giant one here for the 5 volts, and I make a custom heatsink. I don't make it, I buy them, but I have to drill and tap it for 832, and I put heatsink compound between this heatsink and the top of the rectifier. All new electrolytics, obviously. I do put a heatsink now on the -5, the 7905 regulator. I bought a bag of these little T220 heat sinks, and then the correct screws, and it works real nice. The 5 volt doesn't draw much, but I do load test it on my bench, and that really helps dissipate any heat there. I very rarely see these fail though, but what else? We've got some green LEDs here, and then I do socket both of the voltage regulators for the 5 volt and the 12 volt. And then on the 5 volt, I do put a 10-turn precision potentiometer here where you can really dial in the 5 volts. The original version, or the original build of this power supply, had no real provisions to adjust the 5. Well, they did have one leg of a resistor you could snip out and get a couple tenths out of it, but that's not a really great way to do it in my opinion. So I'll actually boot it up here real quick just so you can see the lights on that. They're kind of bright, I'll say. So there they go. And then the 12 volt will persist. So you got +5, 12, and -5. These just indicate power, not that it's adjusted properly. So let me switch back and we'll do some gameplay. And I think this been talking a lot. This video is starting to linger a bit more than I prefer. I'll switch over to the monitor. Okay, let me move this tripod out of the way here. So on my bench, I have little remote control for the power. And again, this is running the original customer's provided linear power supply, and then I've got Williams transformer on the bench as well that powers that. So hit power, get a nice carpet rug pattern there. I do have what's known as a DI box, a direct injection box, where I'm sampling the audio and video now directly digitally, not just filming it. So you can see it boots right into attract mode. That indicates the CR2450 battery, the CMOS, everything to do with persisting the data is carrying over. So I'll coin it up. We should have audio hopefully here. I'll just put some credits on it. And again, I've got a little PlayStation controller that I've built a custom board for where I can map all the buttons and configure it for all the games that I test on my bench here. And if I have a new game that I haven't mapped yet, I can go in and create a profile for it and say I want the analog stick or just the up down buttons, and all of the buttons on the PlayStation, including the L buttons and right buttons back here. I can map any of those, and they just provide essentially the same as a leaf switch contact output. They just ground the circuit. So let me go ahead and start a game here. Get some flapping. Oh, got me. I should say I got myself there. Anyway, you can see she's playing great. Let me drop into diagnostics here. We'll go through a couple of screens. So here you can see all the ROMs test good. Again, the game, when it first boots, it first does this test, the RAM test, and it tests all the DRAM. If that's successful, then it goes on and tests the ROMs. It's actually verifying the checksums in ROM 12 on the board has the code. This basically this application that does the RAM and ROM tests and CMOS and all that. And along with that, it stores the checksums for each of the 12 EEPROMs. So it goes and reads the values, calculates checksums, and compares them. Right now, it's just kind of doing a RAM test. No RAM errors detected. And now it runs another test for the CMOS, everything. And then we go through some sound tests here. We can look through. And then it'll loop back. And the reason they have 6 is there's 6 digital outputs on the board. So literally they're just sequencing binary numbers to change each one of those states from 0 to 1, 0 to 1. So essentially you're testing all of the digital outputs that come off the ROM board that drive the soundboard from the PIA. So you're able to test all 6 outputs by just having 6 sound tests. Early on Defender, they actually tested every sound. It'll loop through 31, 0 through 32 on that. So switch test, again, when I rebuild these I/O boards, I do put splat on the bench because it tests all 18 potential inputs. But for Joust here, you can see move left, right, flap, we got coin, and 1 player start. And if you had the 2 player, all that works because I've tested it all. So, and then you can do color RAM test, and it'll change intensity here. There's some color RAM on the board where you can test this, and then we'll go into grid lines here. This is where you would normally set your convergence on your monitor. Most people these days are not using the built-in, grids and the color bars and all that. You have a little what they call TPG, a test pattern generator that you just plug into the monitor and you can test it. But I guess in the game, if you're having some issues, you could pull this up, and then you get a solid red, green, blue, and then color bars. And then we go into the bookkeeping data. And again, this is here primarily for operators. On the Williams games, they had the coin door, and then below that, they have what's known as a coin vault. And typically, they were keyed differently. So, you'd have an 18-year-old kid working in the arcade, and he'd have a key to the main coin door. So if someone had a jam or the coin didn't register, they could click a credit on and all that. But the money itself, as it fell through, went into the vault where the kid didn't have access, and the operator would come through, at some period, open that bottom door, pull out all the quarters, count them, and then there was a hidden button on Williams kind of up in there. You'd hit it and it would pull up this screen. So they could see how many coins were inserted into the game and make sure that matched up with how many coins were in the vault, if you will, and then they could reset this as well without having to use the diagnostic switches or anything. Just hit the button, record the values, and clear it and move on. So, and then from here you have the game adjustment screen where you can configure how many coins to play, and you can put a message on the screen, and you can do all kinds of set the difficulty level and a track message and all that, and then back to normal track mode. So this has run 24 hours on the bench. I actually finished the board up yesterday about this time, and it's been running since. Just got around to doing the video here. So I'm going to get this boxed up and coming back to Chris and look for you guys in the next video. Thanks so much for watching.